Hi everyone. Now we are going to learn about the traditional methods of sample preparation, which is going to be useful for your GC analysis. Okay, I'm sharing my screen now. Okay, so these are some of the traditional methods for sample preparation of solid samples. Okay, solid samples. Okay. These are the traditional methods, but we also are going to look at some modern extraction methods of solid samples as well. Okay, there are going to be a lot of modern extraction methods, but everything is going to be based on the traditional methods. Okay, because the traditional methods have been proven to be efficient for extraction of analytes from solid samples. First of all, we are going to look at solid liquid extraction, SLE. Okay, so the sample is placed in a closed container and solvent is added that dissolves, extract, or leaches the analytes of interest. So what you can imagine is that you are going to put it inside like a closed bottle. You put your solid samples inside, you put your solvent, you close it, and you let it extract. Okay? So after some time, for example, after 5 hours of extraction, the solution is separated from the solid by means of filtration. That's all. That is the most basic extraction methods. Okay? Sometimes the solvent, if it doesn't go by filtration, sometimes the solvent is boiled or reflux to improve solubility. Sample is in finely divided state to aid leaching process. Sample also can be shaken manually or automatically. It can be left standing here, but sometimes we shake it to make sure that all of the solvent are going to be able to penetrate into the solid samples. Samples also can be filtered, decanted, or centrifuged to separate it from the insoluble solids. Okay, so these are the most simple, the most simplest extraction methods. Okay, now we are going to look at sock slag extraction. Sock slag extraction, the sample is placed in disposable porous container, what we call as thimble. Okay, so thimble ni bentuk dia seperti macam ni. Seperti itu, dia ada pembukaan di atas. It is made up of a porous. Porous tu means that dia ada pore lah kat sini. Dia sebenarnya it is like a white color. But it is made of porous means that the liquid from the inside can go out or the liquid from outside can go in. So that means by porous. Okay, constantly refluxing fresh solvents flows through the thimble and dissolve analytes that are continuously collected in the boiling flask. So for this you are going to see down here. The apa kata tu? Yes. So this is the sock slag setup. Okay, the sock slag setup. So first of all, this is what I meant by thimble. So this is thimble. So your analytes would be in the thimble, your solid. Your solid sample will be in the thimble, and then so this is your extracting solvent. Okay, if you can imagine that, okay, so ini adalah hot plate lah. Okay, kita panaskan hot plate. So the solvent here is going to be heated, and then it will be evaporated kan. So solvent are going to be evaporated and it will flows into the apparatus, go inside here, inside this arm, and then it will go up because it is evaporated. So up here you have a condenser where there is a water in and water out. Okay, so it means that this section is cool. Why this section is cool? To aid for condensation. Okay, your solvent, when it is evaporated, it is in a gaseous form. So it is in, if it is in gaseous form, it cannot extract your analytes. But okay, it goes up here and this section is cool. So it condenses back. It condenses back, it becomes liquid and goes into the thimble. So the extraction process happens here, where your solutes, your solvents are going to be interacted with your solid sample, and extraction will happen here. So bila dimasuk setitis demi setitis, lama-lama benda ni akan penuh. Dia akan penuh sampai sini. Bila dia penuh sampai sini, yang mana yang telah di-extract the solution here. So dalam ni nanti bila extraction dia akan jadi solution solvent plus analyte. Kan? So this solvent plus analytes mixture, once it reaches a certain height, it will go down to this go back into the boiling flask. That is how successful extraction happens. Okay, so basically, when you see here, okay, the extraction heating happens here. These are the extraction solvents, and then the solvent will go into the arm, which is in vapor stage, and then go into the condenser. This area is cool, and then it condenses back into the thimble where your, in this case, herb, where your solid samples are present, and then it interacts with your herb, which creates an extraction process. So after it reaches a certain level, it will go out to the siphon arm and go back into the your boiling flask. So where is your where is your analyte? It's going to be inside here. The extraction process happens here. This extraction process, and your extracts or analytes will be in here. Okay. Other traditional methods such as homogenization, sonication. These are other traditional methods, but it is the most used methods are going to be subslat and solid liquid extraction lah. For homogenization methods, it is that the sample is placed in a blender, and then solvent is added, and then you remove the solvent by means of evaporation curve, filtration curve, it depends. Sonication also by using of ultrasound to create vigorous agitation. So it is the same, you put it inside like a tube, you put your solid, but you apply sonication. So benda ni akan bergetar-getar where your sample are going to be interacted with your solvent much more better. So, and then lastly is the dissolution. Sample is treated with dissolving solvent and taken directly into solution or without chemical changes. So this is usually for inorganic solids. Okay. All right, that is all for traditional methods for sample preparation of solid sample. So I'm going to stop share. Thank you.